Hello, my good students. Welcome back. Let's get some pencils and some paper because today we're going to talk about mathematical problem solving, and it's just kind of an introduction. So get something to write with because thinking and writing should always go together, and I hope that you do some thinking during the video today. So let me share my desktop with you. Okay, so right off the bat, I don't like it. Problem sounds like a pejorative or something like that. So let's not call them problems. I got lots of problems, right? You know, if you got a kidney stone, you got a problem. If you steal a loaf of bread from the store and feel morally guilty, which you should, you have a problem. I'm not talking about that. I'm talking about maybe mathematical question answering introduction. So that's good. What we want to do is we want to use mathematics as a tool of reason. What are the things that reason can tell us? Mathematics allows us to order, describe, and predict behavior in the physical world. In abstract math, there's a connection between abstract math and the physical world. What is it? Why is there this connection between abstract math and the physical world? That's a curious thing. Let's talk now about if we're going to use mathematics as a tool of reason. Mathematics can only speak in terms of numbers. And numbers tell us two things. If you remember from the What is Mathematics video, numbers tell us quantity or numbers tell us size. Numbers tell us how many or how big. And so if something is not necessarily a measure of quantity or of size, then does mathematics really speak to it? I don't know. Can all things be measured by mathematics? I don't think so. So what are the other ways of knowing? And that's a different topic for another time. But let's talk now about the things that numbers can tell us. So let's get into an example here. We're trying to use abstract math to order, describe, and then predict some things. So example number one here, write the following as an algebraic expression and then simplify. So part A is the sum of three consecutive integers if x is the first consecutive integer. Oh my gosh, like what in the world is going on there? Well, consecutive would mean numbers that are right after each other. And so if I don't know it in terms of x, let me write it just in terms of numbers that I do know. So an integer would be another way of saying maybe a positive or a negative whole number. And so what if I just said 5? What's the next consecutive whole number after that? Well, you should say, well, it's 6. And then what's the next consecutive number after that? That would be 7. Okay, so I understand the idea of consecutive now. How do I do it though all in terms of 5? If 5 is the first number, what's the next number in terms of 5? Isn't it 5 plus 1? Yeah, because 6 is 5 plus 1. What is 7 in terms of 5? Well, it's 5 plus 2. But now they tell us x is the first consecutive integer. So what is the first one? X. What's the second one? Well, just add 1 to it, x plus 1. What's the next one after that? X plus 2. See, it's not that hard if you kind of get started on the right foot. So it says the sum. Okay, so now what do I do? What do I do with these things? The sum, I need to add them all together. So now the answer for A would be x plus 1. Maybe you can put parentheses around those if you want. And then plus the next number, which is x plus 2. Now the parentheses are just there to show the groupings. The first number plus the second one plus the third one. But since they're not being multiplied by anything other than 1, I really don't need those. So maybe I'll drop the parentheses. And now I just need to add these up. I'll collect my like terms. Here's an x, and then there's another plus x, and then there's another plus x. So how many x's do I have? 3x. And then if I add up the constants, so plus 3. There's my answer to the first part. Now notice it's not an equation. It's just an expression. Okay? So now let's look at B. the perimeter of the triangle with side lengths of x, 5x, and 6x minus 3. Okay, anything that involves space, I'm going to draw a diagram. So let me draw a little diagram here. I'm trying to draw a triangle. I'm trying not to draw any kind of special triangle. I don't want to draw a right triangle, and I don't want to draw an equilateral triangle because I don't know that those spatial relationships are true in this case. It says side lengths of x and 5x and 6x minus 3. I'm betting that x is the smallest side, so I'm going to label that side x. The next side, 5x, maybe it's this side right here. Obviously, that side's longer than the one I just did, and so that makes sense in the context of the problem. And then the other side is 6x minus 3. And what am I supposed to do? Perimeter. Perimeter. What do you do with the side lengths if you're asked to find perimeter? Well, if I asked you to walk the side lengths, you would then kind of like you'd start in the corner and you'd walk this distance, and then you'd walk that distance, and then you'd walk that distance. So it seems to me like perimeter is just adding them all up. So I would say then x plus the next distance, 5x, plus the next distance, a 6x minus 3. And then I'm just going to collect my like terms again. I got an x and a 5x and a 6x. What's that? 12x? 12x minus 3. There's my expression for the perimeter of that triangle. Can you measure the sum of three numbers with numbers? Yeah. Can you measure the perimeter in units of a geometrical figure? Yeah. So these things are mathematical. Okay. So let me turn the page in my notes. That was pretty easy. Let's look at this one, and then we'll get to some problem-solving strategies. Holy smokes! Example number 2. The 3 busiest airports in the United States are in Chicago, Atlanta, and Los Angeles. The airport in Atlanta is 3.3 parts than Los Angeles Airport. Chicago and 3.3 million more to around. Are you lost yet? Let's keep going. Oh, here we go. Write the sum of the arrivals. See, sometimes on these questions, they don't tell you what they ask you to do until maybe the end. And this one's in the middle, so it's not that bad. But how many questions do you get like this where what they ask you to do is at the end, and they make you read through all of the stuff that you don't care about yet? There it is. Write the sum of the arrivals and departures as a simplified algebraic expression. Okay, so they say let x be the numbers of arrivals and departures of the Los Angeles airport. Oh, so I'm going to be adding something up. Okay, so now let me go back to the beginning. The 3 busiest airports in the United States are Chicago, Atlanta, and Los Angeles. So I'm going to maybe say Chicago plus, what was the next one? Atlanta plus Los Angeles. Now, if I'm going to use variables, which I kind of do, maybe LA is just kind of one variable, but it's still a concept. What I'm talking about is not the population of the city. What I'm talking about is not the air quality as a number. I'm talking about a specific number of things. What do the numbers mean? I'm talking about numbers of arrivals and departures. Okay, so that's what C and A and LA mean. Now, I got to put numbers now to this somehow. The Chicago airport has 1.3 million more arrivals and departures than the Los Angeles airport. And it tells me right here, let X be the number of arrivals and departures at the Los Angeles airport. So that's kind of my anchor. And sometimes I might even draw a little anchor, something like this, a little anchor for my point. I'm basing everything off of what goes on in Los Angeles. So X is the number of arrivals and departures from Los Angeles. And so now I have to replace the number of arrivals and departures in Chicago and the number of arrivals and departures in Atlanta based upon how they compare to Los Angeles. So let me go back in here and read carefully. The airport in Atlanta has 13.3 million more arrivals. Now be careful with this than Los Angeles. So it's going to be Los Angeles, which is X, plus 13.3 million, not 13.3 people or 13.3 departures and arrivals. So maybe it says here, let X be the number of arrivals and departures, not in millions, but just the regular number. So I would actually write in here 13.3 million plus 13,300,000 plus LA. That's Atlanta. So if Atlanta is this little thing right here, Atlanta is that little thing right there. All right. Now, Chicago has just 1.3 million more. So it's going to be LA, which is X, plus 1.3 million more, which is 1,300,000 plus. Okay, that's a little involved now with the big numbers, but you see that I shouldn't really be using 13.3 and 1.3 if I'm actually talking about millions of things. I need to like write the whole thing out. But these big numbers shouldn't scare us. Now let me collect my like terms again. So I'm going to do an x plus another x, so 3x plus, and then I have to add together these two numbers. You probably should not have to reach for your calculator. If I've got 300,000, whatever, and then I add in there 300,000, isn't that 13 plus 1 million is 14 million? And then 300,000 plus 300,000 is easy. That's 600,000. There we go. Am I done? What am I supposed to do again? Oh, write the sum of the arrivals as a simplified algebraic expression. Did I do that? Yeah, I think so, because I can't combine any more than that. There we go. See, it wasn't that hard. You just kind of have to know what to do and know how to set it up. Well, what are you basing it off of? You got to have somewhere to start from, and that was X being the number at the Los Angeles airport. So I've done a couple of these things now. Now let me talk openly about what some problem-solving strategies are. Question answering strategies. Okay, so the first one, and the one that may be the hardest thing to do, you need to think. Okay, you're going to somehow represent the situation with numbers, and the numbers mean something now. It's not just X and Y, and we call them X and Y because we don't know what they are. They mean something. You need to think. You need to understand the situation. You need to understand the main idea. In the previous question, they were asking for write the sum. Here's the key idea here. Write the sum. You're going to be adding some things together, okay? Write the sum. Understand the main idea. Two key subpoints in here in this. If it involves geometry, draw a labeled diagram. If it involves any kind of a space relationship, perimeter of a field, I don't know, a basketball goal that's so many feet high or something like that. If it involves space, draw the space as well as you can and label it. And I did that up here with this problem right there. Here is mine, not just a triangle, a labeled triangle. The length of the sides are given by an algebraic expression. Okay. Secondly, you need to be asking yourself, what's the operation? And I mean, are we adding, subtracting, multiplying, dividing? Like, what's really going on here? What's the big idea in terms of the operation? Okay. Once you kind of get your head wrapped around that, and you don't have to really have all the details in your head, but once you understand the main idea, then you want to choose a variable. Choose a letter to represent the number of whatever they're asking you to find. You don't have to choose X. You could choose something else. In fact, oftentimes I will choose something that makes sense in the context of the problem. Sort of like I did up there with my C for Chicago and A for Atlanta, and then my double LA thing for Los Angeles. Okay. Now you need to remember, what does the number mean? When you answer the question and you get a number for your variable, it means something. What does the number mean? For example, like if we're doing, I don't know, something involving the number of coins, and we're talking about a dime, and so we're going to let lowercase d represent something dimes. What does it represent? Does it represent the number of dimes that I have in my pocket? Does it represent the volume of the dimes in a stack? Does it represent the monetary value of a dime? Like 10 cents? I don't even have to do an equation for that. It's obvious. So the number means something. You need to maybe ask yourself, what does the number mean in the end? It's going to be answering a question how big one thing is, or it's going to be answering a question how many of individual things there are. Make sure that you understand that the variable means the number of something. Number 3, set up a mathematical relationship. And this may be an equation, it may just be an expression here, but you don't have to set it up necessarily with numbers to begin with. Like when I set this one up earlier here, It was a C plus an A plus an LA. I might do something else where I don't actually use numbers or even variables at all. I might just use words. And maybe I'll do one here in a moment that does that. And then you need to solve or simplify whatever you're asked to do, and then check the reasonableness of your answer. Check the reasonableness of your answer. Also check and make sure that you've actually answered the question. Because sometimes you get so lost in answering the question that you forget in the end what you were being asked to do. So let's take a look now at example number 3, finding unknown numbers. All right, so here we go. So find 3 numbers such that the second number is 3 more than twice the first number, and the third number is 4 times the first number. That's nice. Now here's the main idea, the sum. See, remember I told you it's at the end? The sum of the 3 numbers is 164. Okay, all right. I'm going to be adding something together, but now I just don't have to add them. I know the total. So let me just kind of do it in words. I've got the first plus the second plus the third number. Notice I'm not using 1, 2, and 3 as mathematical symbols because that might be confusing. This is an idea of the first. But that's equal then is, see right, equals 164. So the first number plus the second number plus the third number is 164. Now, I need to, what am I asked to find? Find all 3 of them. But they tell me something. They tell me the second number is 3 more than twice the first number. See, this is my anchor here. This is my baseline, the first number. So I will let n equal the first number. So if n is the first number, how do I write the second number? So it's going to be plus, what's the second number right now? Maybe I'll do that in blue just to kind of help you keep it separate. 3 more than, which means something plus 3, twice the first number, so 2n. So there's my second number. My second number is 2n plus 3. And then the third number, add that in there. What's the third number? The third number is 4 times the first number, so 4n. And then equals then 164. Now I've got my actual mathematical relationship set up, and now I know what to do now. Here's the thing. Kids want to start like right here. This is an okay starting place. What's the main idea? You need to think and understand what's going on, and so me writing it out there in words helps me set it up right. Okay, so let's see here. I got n plus 2n plus 4n. That's 7n plus 3 is equal to 164. If I subtract 3 from both sides, I'm going to get 7n is equal to 161. If I divide by 7, this cancels. I get n is equal to, what did I get? 23. Ta-da! I'm done. No, I'm not. Don't get so focused in on the problem that you forget what you're asked. Always go back and check. Oh, find 3 numbers. All right, so the first number, maybe n sub 1, if I want to do it that way. The first number is 23. What's the second number? Well, it was 2 times 23, right? Remember, it's going to be 2n plus 3. So 2 times 23 plus 3. Oh, what did I get? I got 49 for the second number. And then for the third number, it's just going to be 4 times 23. And I get an answer of 92. And now what should I do? I probably should go back and add all these up because the sum of the first plus the second and the third gives me 164. When you add those together, does it give you 164? You should try it. Okay, now here we go. Here's another one. Find the original price of a computer if the price after an 8% discount is $2,162. Now, I'll admit to you a secret. I stole this problem out of a textbook. The textbook did not word it the same way. The textbook had some big old long explanation, and then the final statement said, find the original price. I like to put that in the front, okay? Find the original price. I'm tempted to use O for my variable for the original price, but don't do that because it looks like a 0. So not O, maybe P. I'll call the price. That's what I'm asking you to find. The P represents the number of dollars for the original price. Now it says something, something, something is 2,162. So if I set this up, it's going to be something, something equals 2,162. I can start to see the relationship. How do you find the original price after there's an 8% discount? Well, wouldn't it be the price minus the discount? Isn't that kind of like a subtraction problem right there? Okay, so again, I'm setting it up in words to help me understand the idea. Now, what is the price? Well, I've already labeled that as P. So P minus the discount. What is an 8% discount? Is it not 0.08 times the original price? 8% as a decimal times the original price gives you the amount of the discount, and that's equal to 2,162. There we go, now I can set it up. Isn't this 1p right there? Yeah, so if I subtract that off, I'm going to wind up with 0.92p is equal to 2,162. And maybe you can say, hey, after an 8% discount, I have 92% of the original price left. Maybe you could start right there. I don't know. That would be a little more savvy. But anyway, I solve this now by dividing by 0.92. Divide this out by 0.92, and I get a original price value of, follow my notes here, $2,350. Dollar sign goes in front. Now, is that what I was asked to find? Yes. Is it reasonable? Yes, because it should be more than the final price. If the original price is $23.50 and then you get something taken off, shouldn't you get a number that's less than that? Yes, of course you should. Okay, let's try another one. What are 3 consecutive integers whose sum is 264? All right, I see the word sum. That means I'm going to be adding things, probably 3 things. And here's my equal sign. So I'm going to do the first plus the second plus the third is 264. Now, you may be tempted just to guess and check, but this is not guess and check class. This is algebra class, right? So you need to set it up with algebra. Don't tell me, but I found the right answer. Yeah, but you didn't find it using mathematical methods. You just guessed and checked. This is an algebra class. Maybe sometime later you can take a guess and check class and be good at it. This isn't it. So let me interpret this here. Now, what does it mean, consecutive integers? Didn't we talk about that earlier, right? So if I let the first integer be x, if you want to call it that, what's the next consecutive number after that? X plus 1. And then the next one after that, x plus 2. All right, so now we're finally doing something where it's actually an equation. So the first number is going to be x plus the second number, x plus 1, plus the third number, x plus 2. That equals 264. Okay, now it's set up. Not a problem now to solve those. I'll let you solve those. I get an answer of 87 for x, but I'm not done yet. Let me make my 8 neater. That was ugly. We're about pursuing beauty. 87, and then if I add one to it, that would be 88, and if I add another one to it, that would be 89. There's my final answer to the question. I should probably add them all up and see if I get 264. Okay, so this is not impossible. You kind of have to wrap your head around it. What's the main idea? Let me choose a variable. Usually that's the thing that you're asked to find. Sometimes it can't be, but you want to usually let your variable be the number of whatever they're asking you for. Choose a variable that makes sense in that, like P for price or N for number or something like that. And then look for the main idea and relationship and set it up. Okay, take your time at it. It's not something that comes to you like automatically, like, oh, I just see it. And so it's like, bang, there it is. I get it from the beginning. It takes some layers, takes some thought, takes some paying attention, and it's a process, okay? But it's good. This is using math then as a tool of reason. So how about the next question? Napoleon's problem was how to win the Battle of Waterloo. Explain how he could have fought the battle differently in order to win. There's no equation for that. That is not mathematical. Now, you may involve math, like, hey, I got this many soldiers, and they got this many soldiers, and it's time for something. What time is it? So you might involve numbers, but ultimately, that's not a mathematical question. Now, there probably is an answer to this, which means there are some things that mathematics does not speak to. What are the other ways of knowing things? How would you figure that out? That's some other discipline, okay? This next one's great. I laughed when I made this question up. Show why sentences that end with a rhyming sound please us, and why this influences us to believe that the statement's true. Isn't that funny? Like statements like, happy wife, happy life. And that rhymes. That sounds kind of poetic, right? It's got a slogan sound to it. Is it true? Like, I don't know, but we want to believe it's true. But why is there no equivalent statement for happy husband? Like happy husband, I don't know, happy dust bin? Like that isn't even quite There's no equivalent statement to that because it's very difficult to get something to rhyme with husband. Just because it rhymes, does it make it true? No. Be thoughtful about it. Just because the sound pleases us doesn't mean the idea should please us. Be careful with slogans. But again, that's not a mathematical investigation. So anyway, be patient with yourself. These things take a bit of wrestling to work through. And so like I said, the goal of it is to use math as a tool of reason. Your job is to think it through using the tools of math. Anyway, it's about the pursuit of truth. Don't ever quit pursuing it.